My name is Jeff Cowan. I'm president of Building and Earth Sciences. I've been working in this field since 1983, and we started Building and Earth about 20 years ago. January will be 20 years ago. We're a geotechnical firm. We provide geotechnical exploration services as well as construction materials testing. We do some environmental work also. The geotechnical exploration and reporting part of our services is important because it helps identify the conditions that are present at a site that need to be considered during the design, both from a civil construction standpoint, whether you have shallow rock or unsuitable soils that need to be dealt with as part of the site grading, and also the foundations. We have to identify the proper foundation system to use for a building. But here at the Vestas site, we're underlain by limestone and contact with a dolomite formation. In the Birmingham area where you have these contacts, a lot of times you have a zone where you have very weak rock, deep rock. As we moved up into this part of the site, we got the parking deck and the mid-rise. You reach the geologic contact, and some of the deep foundations in this area had to go as much as 70, 75 feet deep. Understanding these conditions is what is really important when you start a job like this, because it has a great cost impact. So it's very important that you verify that you're down to the rock that you expect it to be. But once we have the foundations in, we're satisfied that they meet the design parameters, and that's when testing and verification and special inspection is part of our work starts over. This morning, Manny's going to make cylinders for the concrete columns. They go from the 11th to the 12th floor. And after each floor is placed, we'll also verify that the post-tensioning cables are stressed appropriately. Manny's our lead technician on the project. He's been handling it. How long have you been out here now?
Since September. All right, this is what we do. We get our sample, we bring it back to our testing area, we do our slump, air, temperature, and make our cylinders. On this one here in particular, what we did was we did a slump, 3 levels. We do not want to bump the slump. Rod it 25 times, strike it off, pull our cone up slowly, and then we'll measure with our tape measure. This particular sample didn't meet our specifications, so we let the harbor know, and they end up sending the truck back. So what they have to do now is order more concrete, and when that trucks come, we'll do the same thing to it, make sure that was in spec. And what we have here is our air test. We do it after we do our slump, measure the entrapped air inside the concrete. This mixer here is supposed to be 4 to 6. We do it the same way we do the slump. The only difference is we tap this each layer. Rod it 25 times, tap it 12 to 15 times. Each layer, that's the only difference. And then once we finish, we'll put our lid on top of it, and we'll put our air in it and just shoot through, get all the bubbles, the air bubbles out of the concrete, and then we'll pump it up to our initial reading. And then once we get there, we'll close our petcocks. And so in this one is 4 to 6, and actually 5.5, so it's within spec. That's good. All right, now what we're doing now is making our cylinders, which is the final step of the testing process. And these are samples we take to the office and we'll break, make sure they meet the required PSI. We break them at 7 and 28 days, and by 28 days, they have to reach the required PSI. Put our lid on it. We'll move it to our space that we're gonna leave it, let it cure. And once we do that, we'll let it cure, like I said, 24 to 48 hours. And we'll come pick it up, take it to our lab and put it in a curing tank. And we'll let it sit for 7 days, and then we'll break it and see what our PSI is on. All right, this concludes our field section of testing the concrete. Maybe next time I see you, I'll show you the fun part when you actually get to break these bad boys. Hey, my name's Emmanuel. I've been working for Building Earth 2.5 years. Hey, welcome to Building Earth.
This is the 12th floor, 17th floor. It is the amenities deck where we have the pool and the amenities on top. Then the 18th floor is the roof deck. So we're on 12, it'll be 6 more. The 3rd floor up to the 16th floor are all typical floors. They're all the same thing. And critical, being able to stay on schedule, is like when we pour a slab, 3 days later, we get our concrete brakes on it. And we get the concrete brakes from Building Earth. We're able to pull the cables, get the report, get it to the engineers, hopefully have it approved that day. And if that happens, then we're able to pick up time on the schedule. Yeah, Emmanuel, he's one of the key guys doing our testing out here with the dirt, the backfill, make sure everything's in compaction. He's on just about every concrete test that we do out here. He does all the cylinders. Like I said, if he does one cylinder, he's done 5,000 cylinders out here. But he stays in touch with us, lets us know the slump, air content, make sure it's the right concrete and the right mix before we put it in place. It's been a real asset to have them on the job with our post-tensioning, our subsurface, our concrete testing. Everything that they do is top-notch and number one. And I would definitely love to have them on any project that I do.
So part of our special inspections requirement on the Vesta project here is to verify that the reinforcing steel is placed according to plan. So you can see here we've had steel going both ways. Also part of that is verifying that the post-tension cables are placed as the structural engineer designed. So here again you see them going both ways. They'll bed head against the edge of the slab after it's poured, and after the concrete reaches strength, then they'll come back and tension the cables. So that's what Greg was talking about, is to get an early break sometimes so they can know when the concrete reaches sufficient strength to go ahead and tension the cables.
My name is Pearson Holt. I work with Building and Earth Sciences as a field engineer. We're out here in Fountain Heights drilling for road improvements, new traffic lights, new light poles, and a raised median in the middle. So Lee and Terry behind me are currently sampling soil. We sample every couple feet, and what is going on right now, that's a hammer, it's a weight, it's a 140-pound weight, and we know how far it drops, so we can reference that to how hard or soft the soil is, give them, the structural guys, a report, and that'll base their foundation design off our report. So this rig is a CME 75, and what we have are hollow stem augers. The hollow stem, they're hollow in the middle, so we drill down to the depth we desire, and then we put a rod in it, a spoon, it's called a split spoon, and we put the hammer on top of it and count how many blows per 6 inches, and we come up with the end number from that. For roadways, it's different. You can get away with softer soils depending on the traffic. Maybe in a parking lot, it can be softer. Depending on how much weight's going on these light poles and how big they are, we usually stop somewhere 8 to 12 is pretty good soils for these. And that's kind of how it always depends. Every area you drill is a little different, even if you're in the same formation. It's not boring, but it's boring. Every day's an adventure at Building and Earth Sciences.
All projects that we work on will have some level of earthwork required. Some may last even as little as a week, others may be a couple of years. The project that we're on today is a residential project, and earthwork on it lasted about 2 years.
We started it in 2016. It was an earth moving project. We designed this dam we're standing on, as well as monitored the construction of it. There's 2 other dams here similar to this one on this project. It's impounding about 100 acres of lake for a subdivision. We monitored all the fill that was placed, each lift as it came up, as well as the soil types. We built a core as well as shells for the dam, and all that was monitored by our field technicians. All right, this project's nearly complete. In a second, we'll take you over to another project that's just getting started, where you'll meet Liam, who is our engineering technician and is monitoring field placement and compaction on that project.
So my name's Liam Crawley. I've been with Building and Earth now for 2.5 years. I'm an engineering technician. Basically, I'm on site when they're doing the active work, monitoring the soil compaction, grabbing density tests. And so basically I was just gonna run through what I do when I get out on site. So in order to grab a test and everything, the first thing we have to do is get us a nice smooth spot. You wanna make sure there's not a lot of voids in there, that way you get an accurate reading. And then depending on the lift size, you have to make sure you drive the pin in deep enough to get a test that tests through the entire lift. So then after driving the stake down to the 6-inch mark, you take the nuclear gauge, you line it up over the hole, and you drop it down to 6 inches. You set the depth to 6 inches, and then you have to, if you could, just step away because it's got nuclear material, so we recommend that you stay about 15 feet away from the gauge at all times when it's running. And so then we have a list of proctors because before I even get out here, they've generally drilled the site, gathered the different soils, and they have given me a list that I can match it up to make sure it is compacted as compared to the proctor. So working with Building and Earth has been really great. I started working with them right out of college. My buddy got a job there and they offer a recruitment bonus, which brought me in and everything. I had majored in geography and environmental science at Alabama and really didn't know where to go with that field, and found this opportunity really productive to my professional development. I've gotten numerous certifications. That's not only increased my take-home pay, but also they offered bonus incentives for this. At the same time, I really enjoy what I'm doing. I'm outside the majority of the day. It's a company that provides really good benefits. You get paid, you're taken care of very well. And it's a company that you truly have the feeling that they care about you. They're concerned with your health, with your safety. They want to empower you to make choices that if you don't feel comfortable doing something, you don't have to do it. It's nice to work for a company that really cares about the employees, their safety, their well-being, and I really enjoy that about the company.
So we've shared with you today some about what we do out here in the field for quality control during earthwork, and we'd like to educate all of you about the services that we do. We have a lot of different types of jobs available here at Building and Earth, a lot of different field activities that go on, and we really hope you consider coming to join us at Building and Earth Sciences.